Hey everybody, this is Dr. Rebecca Oliver, and I put together a little video on how to do basic dosage calculations. So in this video, we're going to learn to read the problems, figure out what information we're given, identify specific types of information, and understand what it is that we're being asked, because all those things become important in helping us solve these types of problems. And then at the last part of this video, I'm going to give you an opportunity to work some of the same type of problems that we worked in this part of the video. So let's go ahead and get started. So here we have a problem that states that we have a patient who weighs 45 kilograms, and this patient is to receive a medication that's dosed at 2 milligrams per kilogram. And we're being asked to determine how much medication should the patient receive. So we first off start by determining what is it that we know based upon what this question is giving us. What information do we have? So one of the things that we can see immediately is that we have a patient that weighs 45 kilograms. And then the next piece of information that we're given is that the medication is dosed at 2 milligrams per kilogram, and that would be our dosage. So I'm going to say let's pause right here and let's look at this information that we're calling dosage. The medication is dosed at 2 milligrams per kilogram. What does that mean? What is that telling us? Well, what this is telling us is that this medication gets dosed at a rate of 2 milligrams per 1 kilogram of patient body weight. That's what that's telling us. And when you have two pieces of information of dissimilar units that you can establish a relationship between, we call that a ratio. So in other words, we're relating milligrams of medication to kilogram of body weight. So this is not an amount. We can't measure that. We can't put it on a scale and say, oh, they get 2 milligrams per kilogram. It's a ratio. And it's basically saying that if you weighed a kilogram, you're going to get 2 milligrams of drugs. Or if you weighed 3 kilograms, you're going to get 6 milligrams of drug. So this is, as you see, a pretty simple problem once we break it down and we look at what they're actually asking us and the information that they're giving us. So this little bit here around dosage suddenly makes things a lot easier for us, because once we can recognize that it's a ratio, we understand that we're going to be able to do some manipulation with ratios. If you've already watched some of my other videos about dimensional analysis, you'll have that background. If you haven't watched those, if you're a little rusty, I'd recommend that you watch the basic one on the nuts and bolts of creating ratios between units. But anyway, we've got this information here that tells us about dosage. So based upon what we know that our dosage is going to be milligrams per kilogram of body weight. But that doesn't answer the question of how much does the patient receive. Well, we have to think about what kind of units is that going to be in. Well, then we have to go back to see what we're given. Well, we're given a weight in kilograms, and then we're giving a dosage in milligrams per kilogram. So the only units that were provided in our information are kilograms and milligrams. Now, kilograms is a large amount. So if we were going to be given drugs in the amount of kilograms, that means that we'd be receiving drugs by the bucketful or by the wheelbarrow load. So we're probably not going to be answering this question in terms of kilograms. So it's more likely that we're going to be answering this question in milligrams. Our milligrams are going to answer the question of how much should the patient receive. So our final dosage amount needs to be in the units of milligram, if we apply a little logic here. So at this point, with this little bit of background, we actually have enough information that we can set this problem up and solve it. So let's do that. So we're going to start with our weight, which is 45 kilograms, and we're going to multiply it by our dosage, which is 2 milligrams per kilogram. And then at this point, once I plugged in my conversion factors, which is what our dosage is, it's a ratio that we're using as a conversion factor, I like to stop and I like to cancel out any repeating units. I like to cancel out any sort of units that appear both in the denominator and in the numerator. And if we look, we can see we have a scenario, and that would be with kilograms. We have kilograms here in the denominator and kilograms here in the numerator, and because they appear in both the numerator and the denominator, they cancel out, and the only units that we have left are going to be in milligrams. And milligrams is what we've determined we want, because milligrams will answer the question of how much medication the patient will receive. Our base unit is the gram, and gram is something you can measure. So at this point, we're going to do the math, which means we multiply the numerators and we multiply the denominators, and we're going to divide the numerators by the denominators. So we're going to multiply 45 times 2, and we'll divide it by 1, and our answer ends up being 90 milligrams. Now here we have a problem where we have a patient who weighs 18 kilograms and is to receive a medication that's dosed at 1.75 milligrams per kilogram. And again, we're being asked how much medication should that patient receive. Now, as always, I like to start by writing what it is that I know, what information has my problem provided me. And the first piece of information that I know is that my patient weighs 18 kilograms. The next piece of information that I know is that I have a dosage amount at the rate of 1.75 milligrams per kilogram. And from the previous problem, I know that dosage is not an amount, it's a ratio. It's giving me a relationship between milligrams of medication and kilograms of body weight. So I'm just going to put that little note right there. So if we start by writing what it is we know that our dosage is 1.75 milligrams per 1 kilogram of body weight. And we also know that our final dosage amount needs to be in the units of milligrams, because it's going to be unlikely that we're going to have medication delivered in kilograms, and these are the only 2 units that were being given in our problem. Now at this point, we have enough information that we can set our problem up and do the math and get an answer. So we're going to start by plugging in our weight, and we're going to multiply it by our dosage, which is 1.75 milligrams over 1 kilogram. I like to stop at this point once I've plugged in all of my numbers and see what cancels, what sort of units are in the denominator and the numerator, and get rid of those, because that starts to lay the foundation of a double checking system. So that if I end up with the units that I want, the units that are going to help me answer my question, if those are the ones that are left in place, then I've pretty much set up my conversion factors correctly. I managed to use my ratio correctly. So in this problem, we have kilograms in the denominator, kilograms in the numerator, and those can cancel out. And in fact, we're left with milligrams in the numerator, which is going to be what helps us answer the question of how much medication the patient should receive. How much? Milligrams. That answers the question. So now we're going to multiply 18 times 1.75. We would divide it by 1, and our final answer is 31.5 milligrams. Now, we need to stop at this point and take a look at significant figures. Our final answer has 3 significant figures, but if we go back to the information that we were given and we see what sort of significant figures that we have there, we can't have our final answer be more exact than information that we're given. Now we're given 2 pieces of information. We're given body weight, and we're giving a ratio. We don't take the numbers in ratios to determine significant figures. They're considered infinite amounts, and something that I don't really get into here, but we don't use the ratios. In this case, we're going to use weight, and the reason why we're going to use weight is because a human being actually had to take that patient, put them on a scale, use that scale as a tool to extract information, and by doing so, that means we have a little bit of margin for error. Maybe it's human error, maybe the eyesight's not so good, or maybe the scale is in a little bit of error, but because we run the risk of having a little bit of error in a measurement that a human being takes, when we do calculations, we cannot have our calculated terms be more precise or imply more precision than a measured value. So in this case, we're going to have to go back to our measured value, which is our patient's weight, and see how many significant figures that we have there. And we have 2, because the patient's weight is 18. We have 2 significant figures, which means our answer, the answer to how much medication the patient received, can only be significant to 2 digits. But we have 3, which means we're going to have to round. Now, in our answer, we have 31.5. These are the numbers that we're dealing with. So we know we're going to keep the 3. We know we're going to keep the 1. But are we going to keep that 1 a 1, or are we going to round it up to 2? Well, in order to do that, we go one more digit past the 2 that we're keeping to this 3rd digit, and we look to that one. Now, if this number here is equal to or greater than 5, we would round up our last number that we're keeping. If this number that we're not keeping is less than 5, our number would stay the same. But in this case, we have a 5, which means that we're going to have to round this 1 up from 1 to 2. And our final answer would be 32 milligrams. Now you may be asking yourself, why didn't I do that in the first problem? Well, if you go back and you look at the first problem, there is a reason why I didn't introduce it at that time. Mostly because I wanted you to get the techniques down, understanding what a ratio is. But if you go back and you look at it, you'll see that it is appropriate to significant figures. I'll let you do that on your own time. All right, here we have another problem. We have a patient that weighs 68 pounds. And this patient is supposed to receive a medication that's dosed at 2 milligrams per kilogram of body weight. Hey, wait a minute. We got pounds of weight and kilograms of weight. How the heck are we going to handle that? Well, don't worry, there is a solution. But we always start by asking ourselves, what do we know? Well, the first thing we know is that we have 68 pounds of body weight in our patient. And the second thing we know is that we have a medication that is dosed at 2 milligrams per kilogram of body weight. Now, from our previous example, we have learned that our dosage, milligrams per kilogram, is actually relating 2 different types of information. Milligrams of medication to kilograms of body weight. And because of that, we know that it's a ratio and not an amount. We can't use that as a dosage amount. So we can't say, oh, they're getting 2 milligrams per kilogram body weight. That doesn't answer the question, well, how much is that? I mean, can you show me that? No, you can't. So we have to make a determination. So our dosage is 2 milligrams per kilogram of body weight. And in this case, the units that are going to answer the question of how much are going to be milligrams, because the only units that we're given are pounds, kilograms, and milligrams in our problem, and we're not being asked to answer in any other units. So we're going to have to look to milligrams to answer our question of how much. Now, our patient's weight is reported in pounds, which means we're going to have to take those pounds and convert them into kilograms. And there is a conversion factor that we can use. There is a relationship that has been established between kilograms and pounds, and it is that 1 kilogram is equal to 2.205 pounds. Now, when a relationship like this can be established, we can use this relationship as a conversion factor. We can write kilograms over pounds, or we can write pounds over kilograms. We can make it look just like our dosage, which is milligrams over kilograms. So we can create a conversion factor that is kilograms over pounds, or we can create a conversion factor that is pounds over kilograms. These are a ratio. It's telling us that for every 1 kilogram, we have 2.25 pounds. So either one of these is correct, but we have to choose the correct one for our problem. And therein lies the rub. So in order to choose the correct conversion factor, there is a little solution or a little rule that you follow, and the rule is this, that the units you seek go on top. And in this case, we have pounds, but we want kilograms, so the kilograms are the units that we seek, which means our conversion factor needs to be 1 kilogram over 2.205 pounds. Now that we've got that in place, we actually have enough information to set the problem up and solve it. So we're going to start with writing our patient's weight, which is 68 pounds, and let's go ahead and multiply that by our conversion factor to eliminate pounds and convert that weight into kilograms. And then we're going to apply our dosage, which is going to let us know how many milligrams based upon patient body weight. So we'll plug in 2 milligrams per kilogram of body weight. Now at this point, now we've plugged in everything. Before I solve it, I like to go through and I like to eliminate repeating units. That is, those units that appear in the denominator and in the numerator. And if everything crosses out, the units I'm left with should help me answer the question of how much medication. And those units would be in milligrams. We've already determined that. So let's start with pounds. We do have pounds in the denominator and we have pounds in the numerator, so those get to cross out. Let's go to our next term. We have kilograms in the denominator and we have kilograms in the numerator, so they cross out. And the units that we have left are milligrams, which are the units that we want in our answer to answer the question of how much. So we're set to do the math. At this point, we're going to multiply all that's in the numerator by all that's in the denominator. We're going to multiply all the numbers in the numerator. We're going to multiply all the numbers in the denominator, and then we're going to divide the numbers in the denominator by the numbers in the numerator. So basically what we're doing is we're going to multiply 68 times 1 times 2, and we're going to divide it by 2.205, and our answer ends up being 61.678 milligrams. Now here we have an answer that has 5 significant figures. If we go back to the information that we were given, we don't have any term that has 5 significant figures in it. We have 2 pieces of information that were given. We have 68 pounds and we have dosage of 2 milligrams per kilogram. Our dosage is a ratio. We don't use the numbers in ratios to determine significant figures. We have to go to a measured value, which in this case is going to be our 68 pounds. 68 is significant to 2 digits, which means our answer needs to be significant to 2 digits. So we know then that we're going to keep the 6, we're going to keep a digit here, it'll either be 1 or we're going to round up to 2, and in order to make that determination, we go 1 more unit to the right, to this number right here, and if this number is equal to or greater than 5, we round our last unit we're keeping up. But if this number here is less than 5, we keep the number the same. We have a 6, which means it's greater than 5, which means that this number, our last digit, is going to get rounded up to 2. It's going to go from 1 to 2, and our final answer will be 62 milligrams. Here we have a patient who weighs 12.5 pounds. And this patient is to receive a medication dosed at 0.25 milligrams per kilograms of medication per body weight. So we have to ask ourselves, what do we know? Well, the first thing we know is that we have a patient that weighs 12.5 pounds. And we have a dosage that comes in at 0.25 milligrams per kilogram. Now, from our previous examples, we've learned that when you have 2 different types of units or 2 different types of information in a fraction form, we could consider that a ratio. Because what this is telling us is that for every 0.25 milligrams of medication, it should be delivered per 1 kilogram of patient body weight. So, and that we can write that out here. And if we look at all of the different units that we're given pounds and kilograms and milligrams. So our answer most likely is going to come in the form of milligrams. So our final units need to be milligrams. Because our patient's weight is given in pounds, we're going to have to convert that into kilograms in order to match the kilograms that we have in our dosage. And to do that, we have a known relationship between pounds and kilograms, which is 1 kilogram is equal to 2.205 pounds. Now, when that relationship can be established between different types of units, we can use that information as a conversion factor, and we can create two conversion factors in this case, actually in every case. We can create a conversion factor where kilograms are on the top and pounds are on the bottom, or a conversion factor where pounds are on the top and kilograms are on the bottom, which means that we have to choose the correct conversion factor for a problem. So in order to do that, we have to follow the rule that says when choosing a conversion factor, you have to ensure that the units you seek go on top. Now the units you seek go on top, which means the units you're eliminating are going on the bottom, which is another way you can double check that. So we want kilograms, we want to eliminate pounds, and the conversion factor that's going to satisfy that would be 1 kilogram over 2.205 pounds. Kilograms are what we seek, they go on the top. Pounds are what we're seeking to eliminate, they go on the bottom. And at this point, we have enough information that we can set up our problem and solve the math. So let's do that. We're going to start with our weight, which is 12.5 pounds, and we're going to multiply it by our conversion factor to eliminate pounds and convert to kilograms. And then we're going to multiply it by our dosage, which is 0.25 milligrams per kilograms. Now, once I have everything plugged in, I like to cross out my units. Those repeating units basically tell me whether or not I've laid the conversion factors out correctly, making sure I didn't flip anything around inadvertently, and that the units that I'm left with answer the final question, which is how much? How much in milligrams specifically for this problem? So let's start with pounds. We have pounds in the denominator, pounds in the numerator, and those cross out. Let's go to our next term. We have kilograms in the denominator, kilograms in the numerator, and those cross out, and the units that we're left with are milligram, which is exactly what we want. So now we can do the math, which means we multiply the terms in the numerator, and we're going to divide it by after we multiply the terms in the denominator, which means we're going to multiply 12.5 times 1 times 0.25 milligrams. We're going to divide that by 2.205, and our answer ends up being 1.417234 milligrams. Now here again we have a scenario where we have far more digits than we have digits in either one of the pieces of information provided to us. And once again, we're going to go to our patient's weight and see what our significant digits are. Well, the patient's weight is reported as 12.5. So this patient's weight is significant to 3 figures, which means our answer also needs to be significant to 3 figures. So we're going to keep the 1. We're going to keep the 4, and we're going to keep something in this third position, whether it's 1 or we round it up to 2. In order to make that determination, we go one more digit to the right, to this fellow right here. And if it's greater than or equal to 5, we're going to round up. 7 is greater than 5, which means that our last digit, which is the 1, gets rounded up to 2. And our final answer is 1.42 milligrams. Now here we have a problem, and we've added a little bit more of information here. So let's read what our problem says. The problem says a patient weighs 52 pounds and they're supposed to receive a medication that's dosed at 0.25 milligrams per kilogram, and it's coming from a solution that is 2 milligrams per milliliter. And we're asked how much should the patient receive in milliliters. Well, let's write out what we know. So we know that we have a patient that weighs 52 pounds. We know that we have a medication that's dosed at 0.25 milligrams per kilogram. And we're also given this third piece of information, which is that we have a stock solution of 2 milligrams per milliliters. Now you see I've written out little notes here, or I've supplied little notes for each one of these. So let's start with our weight. Well, we're given weight in pounds. We know we're going to have to convert it into kilograms. So there's my note there that we need a conversion factor. And this is the established relationship between kilograms and pounds. 1 kilogram equals 2.205 pounds. And like with all of our other dosages, we know that 0.25 milligrams of drug is delivered per every 1 kilogram of body weight, so that's a ratio. But what about this third one? What is this one telling us? About 2 milligrams per milliliter. Well, this is telling you how the drug is going to be dispensed from the pharmacy. It's in liquid form. Liters tells us volume, and we can measure liquid this way. So liters is going to tell us it's coming in a liquid form, and that for every 1 milliliter of liquid that you pour out, it's going to contain 2 milligrams of medication. So we're given two ratios in this problem and a weight, which we're going to have to use a conversion factor in order to get to the right form in order to utilize it. So let's start making our way through this problem. Even though it seems very complicated, once we recognize that dosage and our stock solution are ratios, it suddenly becomes much, much, much more manageable. So the first thing we know is that our dosage is 0.25 milligrams per kilogram of body weight. At this point, hopefully we understand that concept and what this information means to us. We've demystified what milligrams per kilogram means. We now know, based upon what the question is asking us, that instead of our final amount being in milligrams, they're asking specifically for milliliters. Now, they might not have said how much should the patient receive in milliliters. They could have asked us what volume the patient receives. Volume is a measurement of milliliters. So you might have missed that little note, but that's what that means. Milliliters is a volume measurement. But in this case, we've asked for it specifically. We want to know what it is, the dosage in milliliters. And as before, when we have a relationship that can be established between different types of units, we can use that information as a conversion factor. Now, one of the conversion factors that we've been working with in all these previous problems deals with converting between kilograms and pounds. And we know that we can have two different conversion factors here. Well, this is true also with our dosage calculation. Even though it's presented to us as 0.25 milligrams over 1 kilogram, we can also flip it over and say kilograms over milligrams. And the reason why we can do that is because it's a ratio. And both of these terms mean the same thing. It says that you're getting 0.25 milligrams for every 1 kilogram, or 1 kilogram for every 0.25 milligrams. They're basically telling you there's a relationship between these two terms. And we can do the same thing for our stock solution. So even though it's presented to us as 2 milligrams per 1 milliliter, we could also flip it around and say 1 milliliter of solution is going to deliver 2 milligrams of medication. So knowing that we have all these options means that we have to be very careful when setting up our problem and making sure that we plug our conversion factor in the right way. So we're given pounds, and we're being asked to convert to milliliters. So what I'm doing here is I'm starting to draw what's called a solutions map. So we're given pounds, and we're being asked to get to milliliters, but we don't have a direct pathway to get there. So even though we don't have a direct pathway, we have three different sets of terms, and that'll kind of help us out with this. So let's take a look at this first bit of information, the pounds information. Well, we have a conversion factor that will allow us to eliminate pounds and convert it to kilograms. So we're going to move from pounds to kilograms, and in order to do that, we're going to select the conversion factor that has kilograms on top and pounds on the bottom. So let's just drop that in right there. Now, our next term, which is our dosage, gives us a relationship between milligrams and kilograms. Well, we know we don't want our final answer in kilograms, so we want to at least eliminate kilograms when we can. So our dosage is going to allow us to move out of kilograms and into milligrams. So we need to pick the term that has milligrams on top, kilograms on the bottom, so we can eliminate kilograms at this stage. So now at this point, we're in milligrams, but we don't want our final answer to be in milligrams. We want it to be in milliliters. So our last conversion factor that we're going to get from our stock solution is going to have the milliliters on top, the milligrams on the bottom, and that's going to be this term right here. Now, if we stop and we look at this term, that is the opposite of what we were given. We were given milligrams on top, but we flipped it around and we put the milliliters on top. But we can do that because this is a ratio. And whether milligrams are on top or milliliters are on top, it doesn't matter. It's establishing the relationship, and the relationship is the same. So basically, by writing out this solution map for you, I'm showing you that we're going from pounds to kilograms, and then from kilograms to milligrams, and then finally from milligrams into milliliters. Now, although I don't expect you to get this elaborate with it, this gives you a really good visual of how easy solving these problems becomes once you think through and understand where you're starting and where you're going. At this point, let's set up the problem and solve it. All right, so we're going to start with our weight, which is 52 pounds, and we're going to multiply it by our first conversion factor, which is going to get us out of pounds and into kilograms. And then we're going to multiply it by our second conversion factor, which is going to be getting us out of kilograms and into milligrams. And then we're going to multiply it by our third conversion factor, which is going to get us out of milligrams and into milliliters. Now, at this point, once I've plugged in everything, I like to go through and I like to eliminate the repeating terms. I like to eliminate those units that appear both in the numerator and in the denominator. Because as you can see, now that we've got several conversion factors in one problem, it becomes easier for us to make mistakes. But if we scratch through the units that appear both in the numerator and the denominator, that serves as a double check to make sure that we've done everything correctly, so that when we do our math, we're doing the math correctly and getting the right solution. So let's start with our first term, our first conversion factor, and look at the pounds. And we have pounds in the denominator, we have pounds in the numerator, so those get to go away. Let's go to our next term. We have kilograms in the denominator, kilograms in the numerator, so that gets to go away. We have milligrams in the denominator of our third term, and milligrams in the numerator, and the units that we're left with are milliliters. And if we go back to the top and reread the question, we're in fact being asked, how much should the patient receive in milliliters? So that's our double check to know that we've set this up correctly. Now what we do is we're going to multiply the numerator, which is going to be 52 times 1 times 0.25 times 1. And we're going to divide it by what's in the denominator, which means we're going to divide it by 2.205 times 1 times 2. And our answer is going to be 2.947846. Again, we have the scenario where we have far more digits in our answer than we have in our given information in our problem. And once more, we're going to go to the patient's weight, which is 52 pounds. 52 is significant to 2 digits. We want our answer significant to 2 digits, which means we're going to keep the 2, we're going to keep the 9, but do we keep the 9 as a 9, or are we going to round everything up to 3.0? Well, we would go one more digit to the right, which is to look at that 4. Well, 4 is less than 5, which means we're keeping the 2, we're keeping the 9, and our final answer ends up being 2.9 milliliters. So let's work another one of those problems where we're given a stock solution. So here we have a patient who weighs 7 pounds, and this patient is to receive medication dosed at 0.35 milligrams per kilogram of 0.7 milligram per milliliter stock solution. And how much is the patient supposed to receive in milliliters? We could just as easily said, how much volume is the patient supposed to receive, or what volume with the medication would the patient receive? So as always, let's start with what we know, and we know that we have a patient that weighs 7 pounds. We have a medication that is dosed at 0.35 milligrams per kilogram of body weight, and we have a stock solution that is 0.7 milligrams per milliliter, and there's our note about the ratio. So from our previous example, we learned that dosage and stock solution are given to us as ratios, and that we can manipulate those a little bit. And because we're given our weight in pounds, we're going to have to do a manipulation on that with a conversion factor. And we know the relationship is 1 kilogram equals 2.205 pounds. So we have our dosage at 0.35 milligrams per 1 kilogram of body weight. So we understand what dosage means, what these numbers are telling us, what this ratio is telling us. And we know that we're being asked to deliver our final value in milliliters. So we're going to have to set the equation up to make sure that we end up with milliliters. And as before, when you have a relationship established between different types of units, we can use that information to create conversion factors. So for our weight, we're going to have one of two conversion factors. For our dosage, we can have two different conversion factors. And for our stock solution, even though it's presented to us one way, we can still manipulate it and create two conversion factors. So let's set up a solutions map. So we're given pounds, and somehow we're supposed to end up with milliliters. Well, if we look at our first conversion factor, where we're going to get out of pounds into kilograms, we're going to first move from our information, converting it from pounds into kilograms, and we're going to do that with a conversion factor that places kilograms on top and the pounds on the bottom. Yes, it is noon at my house. All right, when we look to our dosage ratio, that's going to get us out of kilograms and it's going to move us into milligrams. So we want to make sure we pick the conversion factor that has milligrams on top and kilograms on the bottom. And then finally, if we look to our stock solution ratio, that's going to get us out of milligrams and put us into milliliters, where we can render our final answer. So we want to pick the conversion factor that puts milliliters on top and milligrams on the bottom, which, as we noted previously, is just the opposite of how that information was supplied to us. It was actually given to us as 0.7 milligrams per milliliter, but we know that we can flip that around because it's the same thing. 1 milliliter per 0.7 milligrams. It's the same information. We haven't changed anything by doing that. So in this way, we're going to be able to convert from pounds to kilograms to milligrams to milliliters and get our final. So let's set up our answer. Let's set up our problem and get our answer. So we start with our pounds. We're going to multiply by our first conversion factor, our second conversion factor, and our third conversion factor. Let's cross out the repeating terms where we have pounds and pounds, and kilograms and kilograms, and milligrams and milligrams. And to double check, we're left with milliliters. And if we go back and read the question, how much should the patient receive in milliliters, we've going to answer our question, and we've set everything up correctly. So let's do our math. We're going to multiply 7 times 1 times 0.35 times 1, divide it by 2.205 and by 0.7, and our answer ends up being 1.587302 milliliters. So this is far more precise than any of the information we were given. So let's go back up to the top, and we're going to use the patient's weight as our determining factor for the number of significant digits. Well, this is only significant to one digit, which means if we come back down, we're going to look right here. Now, do we keep it as 1 or do we round it up to 2? Which means we have to go one more to the right. And here we have a 5, which means we're going to round our 1 up to 2. And our final answer will be 2 milliliters. So now we're in the section of the video where you'll be presented with a problem, and I'll give you a couple of seconds to pause the tape or the video, the tape, showing my age, and it will and then when you hit play again, it'll bring up how I solved the problem and the steps that I did that. What I won't do is I won't go through the what do we know and explaining all the ratios. This will be without sound, but it will be automatic, so you can, the question will come up and you can pause it, work through it, and then hit play and it'll give you the answer. So have fun. So this concludes our video. Thanks for watching, and I hope you found this helpful. Bye-bye.